Hello and welcome back. Mrs. Saunders here. Today we're learning about special right triangles. Not only are these guys just kind of cool, but they're also foundational to concepts that you'll need in Algebra 2, Pre-Calc, and Calculus. So pay attention and get to know these little guys well. When classified by angles, triangles can be acute, obtuse, or right. We started studying right triangles last lesson when we learned about Pythagoras and his theorem, a squared plus b squared equals c squared. Within the world of right triangles, there are two special ones, the 45-45-90 and the 30-60-90. And we call them special right triangles because, well, they each have special properties that are very useful. For these two special triangles, instead of needing two sides to find the third side, we only need one side. We'll start by studying the 45-45-90 triangle. And it's called the 45-45-90 because of its angles. See, 45, 45, and 90. To show you how this works, I'm going to take you through a series of examples where you know either one of the legs or perhaps the hypotenuse. In a 45-45-90 triangle, the two legs, labeled there as x, are congruent, and the hypotenuse is root 2 times the length of the leg. I have here a 45-45-90 triangle and a table to help me keep track of the sides. In the table, I have two legs listed, both labeled x, and the hypotenuse labeled as x times root 2. So let's say I know that one of the legs in this 45-45-90 triangle is 5. I'm going to write that in my table under one of the legs. And since we know that the legs are congruent, see they're both x's, then I know that the other leg is the same, also 5. I'll add that to my table. Then I know that the hypotenuse is the leg 5 times root 2. So I'll multiply 5 by root 2, and there I have my hypotenuse. So with only one leg of the triangle, I could actually find the length of the other two. Let's try another one. The leg is 7 times the square root of 2, so I can put that into my table. Now, if I know one leg, I automatically know that the other one is the same, so 7 root 2 again. To find the hypotenuse, I'll just multiply that by the square root of 2, but I can't just stick another root 2 on the end of it like I did before. I'm going to have to do a bit of math here. So 7 root 2 times root 2. Root 2 times root 2, well, that's 2. And 7 times 2 is 14. So there we go. I know my hypotenuse is 14. It's a bit trickier when you start by knowing the hypotenuse, but it's still not too bad. We just need to reverse the process. So look up here at the table. See where it says x root 2? Well, to get x by itself, I just need to divide by root 2. And then those root 2's cancel, and I'm left with just x. So for this triangle, we know that the hypotenuse is 4 times the square root of 2, so I'll put that in my table. So we're just going to divide by root 2. And so 4 root 2 divided by root 2, those root 2's just cancel out, and we're left with just 4. So that's one of my legs. And if I know one leg, I automatically know that the other leg is the same, also 4. the hypotenuse doesn't have a root 2 just sitting there that we can divide out and cancel? Like this one, the hypotenuse is 6. Well, we're still going to divide by root 2, but again, we might have to do a little bit of math. So 6 divided by root 2. When you divide by a radical, it can't just stay there. We need to rationalize the denominator. So we'll multiply the top and the bottom by the radical we don't want, and then we can multiply straight across. So 6 times root 2 is 6 root 2, and then root 2 times root 2, well, is 2. That's the whole point of rationalizing the denominator. But now be careful because 6 over 2, well, that's a fraction that can be simplified. So this turns into 3 root 2, and that's one of our legs. If I know one leg, I automatically know that the other is the same, another 3 root 2. Moving on now to the 30, 60, 90 triangle, named as such because of its angles. We've got 30, 60, and 90. We're going to start by labeling the short side, and that's across from the 30-degree angle. So find the 30-degree angle, and then straight across from it, that's going to be the short side, and we're going to label that X. In a 30, 60, 90 triangle, what we know is the hypotenuse is 2 times the shorter leg, so 2x. And the longer leg is root 3 times the shorter leg, or x times root 3. "30, 60, 90 triangles are a bit more complicated because, well, 30 and 60 are different angles. Notice on the table, I've labeled a short side, a long side, and the hypotenuse. And it's all about the short side. See how I've labeled that one just x? It's the basis for the other leg and the hypotenuse. So for this triangle, the short side is 6. So I'm going to put that in my table. To find the long side, I multiply that by root 3. So 6 times root 3. To find the hypotenuse, go back to the short side. The short side is 6. Multiply that by 2. So 6 times 2 is 12, and I have the hypotenuse. If the short side already has a radical, that's okay. It's the same process, but we just may have to do a bit of calculation. This time, our short side is 3 root 2. So we'll multiply that by root 3. And look at this. 3 root 2 times root 3 is 3 root 6, because root 3 times root 2 is root 6. The two radicals, they're like terms, so they get multiplied together. So we know our long side is 3 root 6. Now go back to the short side, 3 root 2, and multiply it by 2 to get the hypotenuse. 3 root 2 times 2 is 6 root 2. So when we multiply this times 2, the like terms are the integers. So it's just the 3 and the 2 that get multiplied to get our 6. So if we know the short leg, it's pretty easy. But what if we know the long leg? Well, we need to get to the short leg first before we can get to the hypotenuse. So again, look at the table here. And if the long leg is x root 3, I need to just get x. So to get x by itself, I can divide the long leg by root 3. And then those root 3's cancel out, and I'm just left with x. That's how we're going to get to the short leg. Okay, our long leg is 10 root 3. So if I divide that by root 3, divide that by root 3, then those root 3's cancel out, and I'm just left with 10. I know the short side. So to get to the hypotenuse, I'll just multiply the short side, 10, by 2, and I get 20. I have the hypotenuse. Let's try another one, but this time notice that the long leg doesn't have a root 3 that we can just divide out. We still divide by root 3 to get x, the short leg, by itself, but we'll have to do some simplifying. So we're going to take 10 and divide it by root 3. But again, we can't have a radical in the denominator, so we'll have to rationalize the denominator. We multiply the top and the bottom by the radical we don't want and multiply straight across. We get 10 root 3 over 3 because root 3 times root 3, that's the whole point, just turns into 3. And now we have our short leg. 10 root 3 over 3. So from there, we can multiply by 2. And so if we multiply this whole thing by 2, then we do 10 times 2, and we get 20 root 3 over 3. Finally, what if we have the hypotenuse? Again, we just have to get to the short leg. So if the hypotenuse is 2x, we divide by 2 to get x by itself. Our hypotenuse in this case is 50, so we'll divide that by 2 and we get 25. Now to get to the long leg, well, just multiply that by root 3 and we get 25 root 3. One more. We're starting with a hypotenuse of 2 root 6. If we divide that by 2, we just get root 6. Then we multiply that to get the long leg. So root 6 times root 3 is root 18. Now that's not a simplified radical. We need to simplify that. There's a perfect square hiding there. So root 18, well, 18 is the same as 9 times 2, right? So this 9 right here, that's a perfect square. It can't be inside the radical, so we'll have to kick that out. The square root of 9 is 3, and the 2 has to just stay there inside. So there we have it. Short leg, long leg, hypotenuse. Thank you for being here to learn special right triangles. As I said earlier, these are absolutely foundational to concepts that we'll be learning in later math classes. Just a word of caution though. Make sure the triangles are labeled as 45, 45, 90 or 30, 60, 90 triangles before you just use these special properties. These rules don't work on just any old triangle.